Okay, this is a review of the Chapter 16 review packet. Try and venture through this. Number one, according to Arrhenius concept, an ascent is a substance that donates that increases the concentration of H plus according to Arrhenius. An Arrhenius acid increases H plus, an Arrhenius base increases hydroxide. Number two, definition of a Bronsted-Lowry acid, proton donor, E. Bronsted-Lowry base, proton acceptor. Which of the following is a Bronsted-Lowry acid? B, C, and D are fairly easy to identify as acids. All the above, I'm going to talk about this one. The next one is 4, which is a Bronsted-Lowry base. Okay, acid, 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 so it's not B, C, or D. Now, the one weak base that we know is ammonia, NH3. So if I draw ammonia structurally, it's N attached to 3 H's and a pair of electrons. Now that gets into the Lewis definition, a base being a electron pair donor. So this would react with a strong acid to accept the H. So trimethylamine, that's CH3,3N. This is a base. Now, if I consider the 3 methyl groups, if I replace each H with the 3 CH3, nothing's really changed about its nature. CH3, CH3. So that would act as a base. H plus would be an acid. Now, the result of that would be an extra H on there. And we just use lines because hydrogens, there's a lot of them. Now this would be your conjugate acid. And having the extra H to donate makes that also an acid. So I'm going back to 3 to say that that is the conjugate of this base. And so all these are acids, and only A is a base. Substance that acts as both an acid and a base would be amphoteric. Example would be water, H2O. What's the conjugate acid of NH3? You add an H and you're left with NH4. Make sure we're centered. Okay. The conjugate base of HSO4, if it donated the H, you're left with sulfate. So that's the conjugate base. I have here a very large K, so this equilibrium lies to the right. The things on the left side are stronger, the things on the right side are weaker. Acetic acid acted as an H, cyanide acted as a base. The conjugate of cyanide is HCN, the conjugate of acetic acid is acetate, which means that acetic acid is a stronger acid than hydrocyanic acid, and cyanide is a stronger base than acetate. And so what's left there is CN is stronger than acetate. Same argument here. The KEQ being greater than 1 lies to the right. So the things on the right are weaker than the bases on the left. So HX and Y. HX would be a stronger acid than the conjugate of Y, HY. And Y would be a stronger base than the conjugate of base X. So the answer is the strongest base would be Y on the left. And that's because your K is greater than 1, favoring your products. What do we know about KW? Well, KW is 1 times 10 to the negative 14th. Water ionizes to only a small extent. The molar concentration of hydronium in pure water, 1 times 10 to the negative 7th. The pH of water is equal to 7. You might say 0.00. So the H concentration is the negative log is the inverse log of negative 7. So 1.00 times 10 to the negative 7th molar. In a basic solution, your hydroxide is greater than your hydronium. Which solution has the highest concentration of hydroxide? The one with the highest pH, 12.6, would have the most base in it. Which solution has the highest hydronium? The lowest pH would have the most amount of acid in it. What is the pH of a solution in which the concentration is 3.98 times 10 to the negative 9th? You take the negative log of that number and you get 8.400 A. What's the concentration of the solution with the hydroxide concentration? 2.0. First thing, I would tend to just find the pOH and go backwards, but you can go right from H plus times OH is equal to 1 times 10 to the negative 14th. So H plus being the same thing as H3O. H3O equals 10 to the negative 14th divided by hydroxide, 4.33 times 10 to the negative 11th. What's the pH of a solution that has a concentration of hydroxide? The easiest thing is first to find the pOH. Negative log of that equals 8.400. Then the pH equals 14 minus pOH. The answer is 5.6. The H plus concentration of a solution with the pH of this is what? H plus is is the anti-log, 10 to the negative pH, 10 to the negative 3.75. The answer is 1.8 times 10 to the negative 4th. What's the pOH of a solution that has that concentration of hydronium? Well, first to find the pH, negative log of the concentration of hydronium is 8.400. pOH would be 14 minus pH, 5.600. What's the pH of a 0.03 solution of barium hydroxide? First thing you have to know is barium hydroxide puts out double the hydroxides. So 0.035 solution of barium hydroxide yields double, so 0.07 molar hydroxide. Find the pOH, negative log of 0.07. Take the pH by subtracting 14 from the pOH. The answer is 12.85. An aqueous solution contains 0.1 sodium hydroxide. The pH of the solution is what? Well, your pOH would be the negative log of 0.1, which is 1. So pH equals 14 minus 1 equals 13. An aqueous solution contains 0.15 molar HCl. What's the pH? It releases 1 hydronium, so it's the negative log of 1.5 is 0.15 is 0.84, 824, or just 0.82. Okay. Which of the following is not a strong acid? Yeah. If it ain't strong, it's weak. You should know your 7 strong acids, and the one we have here is nitrous acid. All the strong acids are molecular compounds. All the strong bases are ionic. Acids only ionize when you put them in water, and it hasn't mentioned that. In their pure form, they're molecular. We call them molecular acids. Okay. I think I went over this when we're still in class. BCA tables. You have 800 of 1 molar sodium hydroxide. I would take 800 times 1 to find the fact that I had 800 millimoles and 3.5 of HCl, so it would be 200 times 3.5, and I find out that I have 700 millimoles. I'd use millimoles. And millimoles, 700 millimoles is your limiting, so you don't have any HCl left. You have an excess of 100 millimoles of sodium hydroxide. Now, instead of converting, I would just say, let's define hydroxide as millimoles over milliliters. So I would take the excess 100 and divide it by the total volume, which was 800 plus 200. So you have 1,000 milliliters. And your hydroxide concentration is 0.1 molar. Take the negative log of 0.1, it's 1 molar. 14 minus 1 is 13. Okay. Of the following, which one's a weak acid? You should recognize HF as a weak acid. Which one of the following is the weakest? The one with the smallest K. D. In the following solutions, which one exhibits the highest percentage ionization? The one that ionizes the most would be the one with the strongest K. So the highest value for your K is 6.8 times 10 to the negative fourth. It would be C. And all their acid strengths are the same. Which one ranks from weakest to strongest? Your strongest should have the lowest pH. And from there, this one is double this concentration. So I would say X is definitely your weakest. And then because Z has double the concentration but the same pH, that means Z is a weaker acid than Y. So Y would be more dissociated because it has the same pH, but it's half the strength of Z. All right, I'm going to finish the last on a different video clip, so I'm going to shut this down.